everybody. Welcome back to ACU. I hope your time of quarantine is proving to surface some sort of blessings in your life, whether that is more time with your family or more time with the Lord, reading scripture. And my prayers are going out to all of you that you all may be safe, your family members, your older family members, that they can be safe in this time, and that we're just drawing closer to the Lord and to our families in this time. So right now you're probably at activity 4 in your lab on atomic spectroscopy. Um, I'm going to show you some things here that will help you to do activity 4, and I'm also going to show you some things that help clarify a little bit of some of the things that you've already done in this lab. So on the table, we have three things here. Right over here, I'm trying to get the right angle. Right here we have a bunch of glass tubes of different gases. Here we have our lamp. So what we're going to do is we're going to put one of these glass tubes into the lamp, and what the lamp does, it kind of electrifies the gas inside those glass tubes. If you know, if you've taken chemistry already, you should be a little bit familiar with this concept already. What we're doing is we're shooting energy into the atoms of the gas inside this tube. And what that does is that will make, in a really simple explanation, that makes one of the electrons go from one energy level up to another energy level, another orbital in the atom. But the atom doesn't like that. That's not the natural state of the atom. That's not what the atom naturally likes to do. And so, as soon as that atom finds an opportunity to get back to its original state, for that electron to go back to its normal orbital, in other words, the moment that energy isn't being pushed into this atom, that electron will drop back to its normal orbital. But then it loses some energy. And that energy is shot out of the atom in the form of light. Okay, so the energy was first put into the atom in a form that wasn't light, but then when it shoots back out of the atom, it's in the form of light. And each of those light waves has a different frequency depending on the atom. So if you have a nitrogen molecule, the frequency of that light wave is going to be different than an electron shifting orbitals from, let's say, an oxygen molecule. And so that's why we get the different colors. And so that's really cool. So we're going to take one of these glass tubes, we're going to put it into this lamp, and then I'm going to explain this to you, but let me show you this really quickly. So here we have all of the elements that you've done so far. I'm just going to take air here. You can see there's a glass tube right there. And we are going to put, oh, it's upside down, one sec. Okay, we are going to put it into this lamp. Okay. And I'm going to, there's a switch on the back, I'm going to turn it on. And it makes something like something that you've seen from Star Wars. Actually, this is way cooler than anything I've seen from Star Wars. You guys are really missing out by not being here in lab. And so, yeah, it makes this really cool purple beam. And I'm going to put it over here by the spectroscope. This is our spectroscope. Okay, so if you look on activity 4, here I'm going to position the camera real quick so that the camera isn't shaking all the time. Okay, so here we have our spectroscope, and we originally were going to use really small versions of this in lab, but we have this really big one. And I'm going to move the light source of the spectroscope. Okay. All right. So this is upside down, um, but you should be able to understand how this is similar to the little diagram that you guys have in Activity 4. So if you look in Activity 4, you're going to see this diagram. This is upside down, but I'm going to show you what this looks like. I just want to show you something really quickly. This says it's labeled property of ACC. So this thing is really old. It's probably been around since my grandpa was here. He graduated in 1956. Maybe some of you have some family members. Yeah, the physics lab has a lot of relics in it. It's really cool. But this is just a really simple box. It's not anything that you have to be really delicate with. Okay, so on the big end of your spectroscope, we have the slit. The slit is located right here. And the light source passes through the slit, and it goes all the way over to here. And you put your eye right here, and you look in, and then you can see that light coming through. Now I'm going to pull something out of here. Okay, so here is a little lens, and this is the diffraction grating. It's also very old, but it says 13,400 lines per inch. So there's a whole bunch of tiny microscopic lines on this piece of plastic, and that's really all that it takes to diffract light. In other words, to take normal light and to separate all of its different colors, to just make the colors spread out over distance, like a prism, like you've seen with a prism. It makes those little rainbows. And so what happens when the light comes through here, it goes through the diffraction grating and into your eye. And what happens to the light is the diffraction grating splits it into 3 different directions. Okay, so the first direction is just the normal direction. It just keeps going straight. And the other 2 directions split with an equal angle in opposite directions, like this. Okay. Well, this one, we don't really observe the one that goes out here, but what we can see is the one that goes this way. So when it's diffracted and then this light goes this way, our eye sees that diffraction, and it kind of creates an optical illusion. If our eye is here and we're seeing a light coming from this direction, it basically looks as if the source of light, of diffracted light, is coming from this area. And so what happens is, as we're looking through here, it looks like there's a rainbow shining on this scale. By the way, the scale is right here. The instructions tell you to put a sketch and label of where the scale is. In the pictures that you guys were looking at earlier, that's those numbers that tell you the wavelength of the light that you're looking at. And it just makes it look like there's an actual rainbow that's shining on the scale, but in reality there really isn't. The light is not reflecting back this way. It's just going here and straight through to your eye, but it looks like there's a rainbow over there. And I think that's all you need to know for this. There's a few other things right here, but that's not really important. If you scroll down a little bit more, if you look on the next little part of Activity 4, you'll see another little diagram that shows a laser going through your spectroscope, and it's essentially doing the same thing, except you're going to see that when we work with that you can actually see the lasers that are shooting out onto the wall. It doesn't do that with normal light, because normal light kind of spreads out and then you can't see it after a really short distance, but with the laser you can actually witness the light spreading out into those two directions. I think that's all you need. Email me if you have any questions, and I hope you're having fun clicking buttons.